Good afternoon. These are your notes for lesson 15-2. It's constructing geometric sequences. So remember, in a geometric sequence, each term is multiplied by the same number to get the next term. It's the common ratio. So it says determine if each sequence is a geometric sequence and explain. So to do that, we're going to divide the second term by the first term, the third term by the second term, and the fourth term by the third term. Okay, and they all have to be the same. So I have 4 divided by 2 is 2. 6 divided by 4 is 3 halves. Okay, and if you get two different numbers, you can stop right there, and you can say no. There is no common ratio. Okay, the second one, zoom in there a little bit. So I would do 8 divided by -4, which is -2. -16 divided by 8 is -2. And then 32 divided by -16 is also -2. So when you have the same ratio, you can say yes, the common ratio is -2. For the third one, there's 16 divided by 32, which is 1/2. 8 divided by 16 gives us 1/2. And 4 divided by 8 gives us 1/2. So again, yes, the ratio is 1/2. Okay, we're going to kind of skip this middle part, and I'm going to let you know that and you might want to pause your video here and get these written down. For the explicit formula, we're going to use f of n equals f of 1 times r to the n minus 1. And for the recursive, we're going to use f of 1 equals x, and f of n equals f of n minus 1 times r. Okay, so for 4 and 5, it says each rule represents a geometric sequence. If the given rule is recursive, write it as an explicit rule. If the rule is explicit, write it as a recursive rule. Assume that f of 1 is the first term of the sequence. Okay, so number 4, this is written as a recursive rule. Okay, so we need to write the explicit. I need to know what f of n is, and I also need to know, or f of 1, excuse me, and r. Okay, to get those, obviously this tells us f of 1, and then in a recursive rule, r is at the end. Okay. Zoom in, sorry. Okay, so if I'm going to write the explicit rule, it's going to be f of n equals 2 times 3 to the n minus 1. And that's all there is to it. Number 5 is an explicit rule. So I'm going to use that to write the recursive. In an explicit rule, this first number is f of 1, and this 2 would be the r. So I'm going to say that f of 1 equals 5, and f of n equals f of n minus 1 times 2, and we have to add on for n is greater than or equal to 2. Okay, and what that means is the n, I won't find the first term, but this will work to find terms 2 on up. Okay, it is not the ratio. Okay, on our extra notes, the first examples are constructing recursive and explicit rules. So number 1, it's a table. the n, when you're given a table like this, n is where the number is at in the sequence. So the first number in the sequence is 7, the second is 14, third is 28, and so on. So my actual sequence numbers are the f of n. So the first thing we have to do, well, the only thing we're missing is the ratio. So to get the common ratio, we do the second term, 14, divided by the first term, 7, and end up with a common ratio of 2. So we're going to write the recursive and then the explicit rule for this sequence. So to write the recursive, the first thing we have to do is say that f of 1 is 7. It's our first term. And then f of n equals f of n minus 1 times 2 for n is greater than or equal to 2. Oops, sorry. Okay, and then the explicit rule would be f of n equals 7 times 2 to the n minus 1. Sequence number 2 is 128, 32, 8, 2.5, so on. This is getting smaller. So when it was getting bigger, we had a whole number ratio. When it's getting smaller, it's going to be a fraction, or in this case, because they used a decimal, we are actually going to use a decimal. So to get r, we would do 32 over 128, and that is 0.25. So again, I'm going to write the recursive and the explicit. So for the recursive, I have to say that f of 1 is 128, and f of n equals f of n minus 1 times 0.25 for n is greater than or equal to 2. Okay, and the explicit rule for this would be f of n equals 128 times 0.25 to the n minus 1 power. Alright, the next thing we have to do is construct geometric sequences given two terms. So write an explicit rule for each sequence using subscript notation. So we have to do, it's a process to find these guys. Not hard, all things we can do, but it is quite a process. So the first thing you're going to do is identify the given terms. So this is what a subscript looks like. It's a sub 5. So that 5 is the term number. So that's telling me that 1/60th, and 1/60th is the term that's actually in the sequence. But 1/60th is the 5th term in my sequence. And they also give me a sub 7. So that's telling me that 1/15th is the 7th term in the sequence. Okay? The first thing we're going to do is find a ratio. You're going to set it up. I'm going to turn my paper sideways because this is where I wrote it. It's going to be the higher term equals the lower term times r to the difference in the two terms. Okay, might want to pause and get that written down. Excuse me. So, and I'm going to write it out using all the variables first. So the higher term would be a sub 7 equals the lower term would be a sub 5 times, and we don't know what the ratio is yet, so r, and the difference in my terms is 2. So to the second power. Now I'm going to go ahead and fill in what these actually are. So a sub 7 is 1/15 equals a sub 5 is 1/60 times, we still don't know r, that's what we're solving for, r squared. To start solving for r, we have a fraction, so we would multiply by the reciprocal. So that's going to be multiply both sides by 60. 1/15 times 60 is 4. 1/60 and 60 cancel out, so I'm left with r squared. Okay, to get rid of a square, we need to do the square root. Square root of 4 is 2, so our ratio is 2. Okay, the last thing we have to do is find the first term. To find the first term, we're actually going to use the explicit formula to get it. So this would be a sub n equals a sub 1 times r to the n minus 1. This is the same thing as the f of n and f of 1. We're just using subscript now. So, and the reason for the a I don't know. It's just what they use. A sub n is a term. It's got to be a term in the sequence. So we were given 2 terms, so you can actually pick which one you want. And then when you're substituting, this n right here is the term number. And you can use either term that they give you. I'm going to go ahead and just pick the first term, which was 1/60. So I have 1/60 equals, and we don't know a sub 1 yet, so a sub 1 times, we know that our ratio was 2, so this is going to be times 2, and then the term number, well, 1/60 was the 5th term, so to the 5 minus 1 power. Okay, now we just need to solve for a sub 1. So the first thing you have to do is subtract the 5 and 1. So I have 1/60 equals a sub 1 times 2 to the 4th power. To evaluate 2 to the 4th power, which is 16, so I have 1/60 equals, and I'm going to go ahead and put the 16 first, 16 a sub 1. And then to get rid of the 16, you would divide by 16, or because we have fractions, I can say that I'm going to multiply by 1/16 because it's the reciprocal of 16. 1/60 times 1/16 is 1/960, and on the other side we're left with a sub 1. So now that I have my first term and my ratio, I can actually go back with these and I can write my formula. So it would be a sub n, which is just like f of n, equals 1/960 times, my rate is, ratio is 2 to the n minus 1. Okay, let's do one more. We know you guys love fractions, so we chose fractions to work with for our examples. So again, here are my terms. Okay, so we're going to find the ratio. So it's the higher term, so a sub 5 equals the lower term, a sub 3, times the rate, or ratio, to the difference. So I have 5 and 3, so again, my difference is 2. If they had given me term 5 and term 2, it would be r to the 3rd power. Okay, so it's just whatever these two, the difference in these two numbers is, belongs here. So a sub 5 is 1/243rd equals a sub 3 is 1/27th times r squared. To get rid of 1/27th, I need to multiply by 27. 27, or 1/243 times 27 would give you 1/9 equals r squared. And then take the square root. My ratio is 1/3. Okay. So we're going to come over here and find the first term. And I'm going to go ahead and write the explicit formula out again. So it's a sub n equals a sub 1 times r to the n minus 1. And I'm going to fill in what I know. I am going to choose the first term they gave me. So 1/27 equals a sub 1 times our ratio, again, is 1/3. And 1/27 was the third term, so it's to the 3 minus 1. Again, I need to do the 3 minus 1, so I have 1/27 equals a sub 1 times 1/3 squared. 1/3 squared is 1/9, so I have 1/27 equals 1/9 a sub 1. Multiply by the reciprocal, so I'm going to multiply both sides by 9. 9/27 is 1/3 equals a sub 1. So again, now I have my first term and I have my ratio. So I can come over here and I can write out my formula. So it is going to be a sub n equals 1/3 times 1/3 to the n minus 1 power. Okay. If you have any questions, you can please drop by and see us before or after school. Okay, your homework with this lesson is 15.2, page 541 through 544, and it's going to be problems 2 to 24 even. All right, and have a great day, guys.